now. But yeah, we're really, really excited to have a really fun transition session again today. It's been a little while since we've had one because we were able to get a lot of people through. So I think people are starting to transition again. So this should be a great time. So I don't want to take any of your time. We'll do networking at the end, so you guys have plenty of time to talk about your research. And we are going to start with Azhar. So Azhar, go ahead and share your screen, and we're excited to hear what you've been doing.
Yes, hi everyone again. So today I'd like to share about about myself. So okay. So I'm really new in proteomics. So I came from Kazakhstan. It's a Central Asia of Asia. So I came from Kazakhstan to the Hungary for my master program, molecular biology. So I graduated molecular biology last year. And since last year, I joined for proteomics core facility in Hungary as a research technician. So my projects was entitled with and data independent acquisition techniques. So I have to prepare, develop and optimize the specific acquisition technique, especially data independent acquisition. So I start learning about the data dependent acquisition techniques, and after that, data independent acquisition techniques in the mass spectrometry. So the main task was probably most of them was about the sample preparation and then development of the instrument method, and then after instrument method I run the raw data and then analyze the data. So in the laboratory mostly so I started with digestion as a main thing. And so I learned labeling and different creating instrument method, Excalibur and thermo instruments, and plus analyzing the raw data on MaxQuant. It depends on the data dependent or data independent acquisition, which I use. So I try to use different softwares for that. And also I learned about the coding. So Java and command lines and other statistics softwares and R programming. So this is my lab and my manager, she's Eva Chos. She's a almost professor. Actually, yeah, she's professor. And my colleagues, so we are every year participating on the Human Proteome Organization conferences, and plus participating in different winter and summer symposiums of the Hungary. And my future goal is to find a perfect PhD in proteomics or in biochemistry. So I'm applying nowadays for United States universities. I'm really how to say green about what kind of universities is providing the proteomics specifically with with the mass spectrometry analysis and about the techniques. So I know the PhD is not something easy. So I know it's really hard. So I hope I can find the perfect PhD in the United States next year. So I'm applying for fall 2022. So that's all about.
Nice, thank you so much. And so your transition, your goal is to transition to a PhD program?
Yes.
And you want to stay in proteomics?
I can be between like proteomics and genomics.
Gotcha. No, that's great to know. But yeah, great hand of applause. So everybody go ahead and give her a virtual hand or a regular hand. And then any questions for Azhar?
Because I have a question, would be geographically, what's your target in terms of a PhD program? Where in the world would you prefer to be located, if any?
So I am I'm going to apply for 5 or 6 universities in the United States. So I'm checking the rankings and other projects, what the universities is doing. So so in US, I don't know, like I'm thinking one of the option probably the Chicago University, and so there are other universities also I'm applying.
Yeah, and I would definitely recommend to reach out to some of the professors like Stephanie Colonia's at Chicago or some of those, and make some connections there. And that helps them look specifically for your application if they're on the admissions committees.
So since I'm actually accepting PhD students next year, so I am at George Washington University in Washington, DC. So I'd like to learn more about actually the specific projects you work on, but we can definitely schedule like times to talk later. So I think this is a great platform that you can get to like show what you need to do, and then the audiences and the people will help you reach your goals. Yeah.
Yes.
Yeah,
Thank you.
Yeah, you two definitely connect. That would be awesome. Any other questions for Azhar? Great job, Azhar. So we'll give you a round of applause again, and we'll let Carolina go next.
Thank you.
Share my screen. Can you see PowerPoint okay?
Yep, just popped up.
Okay, nice. And then swap. Are we good?
Yep, perfect.
Nice. Well, thank you so much for FeMS for this opportunity to start my job hunt. So who am I? My name is Carolina. I'm originally from Colombia. I moved 15 years ago to the States. A little bit more about me. I love embroidery. I have embroidered the last 4 lab coats that we give to like each recent grad student, and I'm working on the current next 4. I love video games. And of course, I love science. So I acquired a Bachelor of Chemistry from William and Mary, where I focus on inorganic chemistry. And in order to check like the purity of our synthesis, of course, we use Mass Spec. That's when I started falling in love with Mass Spec. So much that for my next step, as a postbac at the NIH, I work at a Mass Spec core facility. So it was Mass Spec 24/7. It was all the basics of bottom up, like sample prep and data analysis. I also did some intact protein measurements. But something that frustrated me was that users would come like, oh, I have this membrane protein. What are the lipids bound to it? And I was like, what? Intact? What do you mean? Intact protein? So native Mass Spec, they were talking about native Mass Spec, and I was like, oh no, I need to learn more about this. So I decided to do a whole PhD about it with Professor Brandon Ruttle at the University of Michigan, where I combine native mobility mass spectrometry and radical-based fragmentation for top-10 structural proteomics. So what does this entail for me? I have learned how to program. I have learned for languages, because our data sets sometimes are so hard, and in like bottom up where you're like overwhelmed by the amount of tools. In native, we don't really have a lot of tools. So I have learned skills about native mass spectrometry, how to keep the proteins happy so we can spread them intact and retaining non-covalent interactions. I have experience in 2 types of mobility, and I have experience in software from both Agilent and Waters vendors. And something very proud of, I was top 10 ASMS trivia last year. Yeah. Thank you, Erin. It was very fun. And then for today, due to our time constraints, I'm only going to focus on chapter 4 of my thesis, which is annotating collisional induced unfolding using electron capture dissociation. It was an oral in last year, a conference, and it will be a remote poster. And I'm talking about this one specifically because it's the one that has made me suffer the most, the project. And I love some outreach. Shout out to outreach. So let's go through some native mobility mass spectrometry 101, which requires a lot of patience. Let me, my pointer here. So in native ion mobility mass spectrometry, we use nanoelectrospray to transfer our protein ions from solution to the gas phase. Then we use ion mobility, which is pretty much electrophoresis in the gas phase to separate our protein ions in a drift tube under a weak electric field full with neutral gas particles. So if the protein ions are extended, they will collide more with the particles and have a longer drift time. Then we separate them by typical mass to charge. And then these drift time values will be converted to collisional cross sections, which can be thought as like a average shadow of the particle or of the molecule, sorry. And then the CCS values can then be compared to values obtained from other techniques, so we know how native-like our ions are actually. Unfortunately, as protein ion size, as mass resolution, if the ion increases in size, there's less resolution. So in ion mobility, we see blobs for pretty much like the resolution is so low in IM for antibodies that if you put a PTM, they're gonna have the same, pretty much the same cross-section, unless it has a dramatic effect in structure. So this is not very useful in protein engineering because sometimes the difference is just one amino acid. This is where collision-induced unfolding comes in, which is able to separate subtly different protein variants based on the unfolding patterns of the protein. So I monitored the drift time as I increase the internal energy through collisions of the ions. We represent this as a heat map, like I have in my background, and then regions where the protein is stable through several voltages are called features. And the transition between these features are what we use for stability. For example, if we add a PTM and the same transition from the wild type shifts to a higher voltage, it means the PTM has made this construct more stable. However, what if we don't have, like, let's say, a crucial structure, or what if we don't have idea where the mutation happened? We don't really know how the unfolding is occurring. So this is where I come in, and it was a collaboration with industry. I'm using a modified instrument for collision-induced unfolding ECT experiments. What does this mean? There is a protein that has a known unfolding pathway, and this human serum albumin that has 3 domains with domain-specific ligands. We know it's unfolding due to the monitoring the ejection of the ligands throughout the unfolding pathway. Domain 2, partially domain 3, and then domain 1 unfold in that order. So we know how each unfolds. Therefore, I'm putting it in this modified Agilent 6560 ion mobility quadrupole time of flight. The instrument has 2 modifications. If you notice, the regular collision cell is after the IM, which won't allow me for CIU. So it has been modified in the front to unfold such molecules as large as antibodies. And then we have an electromagnetostatic cell in front of the shortened collision cell. This allows for ECD, so I'm exposing my protein ions to low energy electrons that give fragmentation from regions undergoing unfolding. So I require a lot of creativity to handle this data set. So here I have CIU ECD data from intact human serum albumin. In the upper right, I have the unfolding pathway of HSA, and in this color box, I'm highlighting where I'm obtaining the fragmentation. And if you see to the upper left, I have a few ions annotated from the N-terminus. Okay, N-terminus are floppy, but where is like other regions of the protein? So as I unfolded and the protein opened up, the fragmentation changed dramatically. And I was seeing more fragments from the N-terminus. And there was these large chunks of the protein that didn't map to any terminal fragments. So, and these ones were the most feature-dependent peaks. So they were involved in the unfolding of the protein. And I'm just highlighting it. I don't have enough time in the presentation to go, but I had to put some programming gloves and write several scripts. Otherwise, I wouldn't have been able to move the project forward. So did the scripts work? So here I have a crucial structure of human serum albumin with 17 disulfide bonds highlighted, which made the analysis harder. Here I have in color 2 internal fragments. The purple one is 5 charges and the teal one is 4 charges, and each one has some modifications I needed to take into account for breaking of the disulfide bonds. In color, I have highlighted the domains. So the purple one is mostly present in domain 2. And guess what? When I monitor its intensity, it actually starts appearing and after the first unfolding transition. So it matches what we saw from the ligand ejection data. Then the teal one is actually 50-50 between domain 1 and domain 2. And it appears again like the purple fragment, but it reappears after like the other unfolding events because domain one unfolds at the end. So our future goals is to perform MD simulations of the unfolding of HCA guided by these ICD fragments. More about me. So I'm almost at the end of my PhD, and I thought I was just a very anxious person, but actually I have POTS. I just discovered that a few months ago. So it means my autopilot is broken. I have some issues with energy, temperature, and I guess I'm like, oh well, I feel a little bit proud of myself that I survived a PhD without knowing I have POTS. Which I'm thinking about is in positive lights. I'm like an astronaut. I didn't know I was getting astronaut training, but not in space. But yeah, I'm a disclaimer. I have POTS because that has informed about my next career steps. So I love Mass Spec. It's more of a hobby than a job. So I'm still looking for Mass Spec related opportunities in industry, government, postdoc, but I'm switching to full computational because it's a little bit tough for me to go in person to the lab. So I have acquired some basic skills on demand data analysis, tool development, or programming languages. Coming soon, I'm working on learning molecular dynamic simulation for the CIUCD experiments. And I'm indeed open to work in the bench because I enjoy working in the bench, but let's see how it goes. An ideal location, the northeast of the United States. I should put the United States, and it would be mostly remote grade. But yeah, no, thank you so much for my group for having so much patience with me, funding sources, and thank you so much for your attention.
Nice. Thank you so much, Carolina.
No, oh, how do I? Let me. And show it.
So does anybody have any questions for Carolina?
Hi, Carolina. Can you guys hear me?
Yeah, I can hear you. You're a little bit quiet. It's Carolina.
Oh.
Sorry.
Oh, Carolina. Sorry. Hi. Sorry, I wasn't sure if my microphone was working.
You
It's
sound
nice
good
to see
now.
everyone. Okay. Hi, Aaron. Hi, Ling. Hi, Beanie. Yeah, great presentation. It's really cool that you've done the post-bac program at the NIH. I'm actually recently started as a tenure track investigator at the NIH in Baltimore, and I'm looking for people. So
Wow.
you know, perhaps after this we can connect. So my lab's mostly a a bottom-up proteomics lab. So it's a bit going back to the stuff you've done before.
Oh,
at
I
the
love bottom up
NIH.
too.
Yeah, so we're really interested in applying, mass spec-based proteomics to aging and age-related diseases. So, after this, we should connect more. I really liked your
Yes,
presentation.
I'm looking forward. I miss the NIH a lot, and I learn a lot there. So it'd be fun to go back.
Wonderful.
Thank you.
Sure.
Yeah, I guess I'll comment. So I'm Melissa, I'm the CEO of Mobile Ion Systems, Inc., and we're commercializing Dick Smith's high resolution SLIM based ion mobility technology. And we're always looking to add people to our team. So, I welcome the opportunity to connect also and I can make sure that your resume makes it into our system. And if that's something you're looking for, we're located outside of Philadelphia. So mid-Atlantic, East Coast, close to Baltimore. Yeah, so happy to help in whatever way I can.
Oh, thank you so much. Congrats about the commercialization of Movi. I saw that.
Thanks. Yeah, thanks.
Hey, Carolina. I'm at the National Institute of Standard and Technology, so a government. I'm currently a NRC postdoc. And so I would suggest if you have citizenship to look into those postdocs. Because at least at NIST, I know that there's actually a whole group that does a lot of computation application to Mass Spec. And we are right now on almost full remote.
Oh, wow.
For
Nice.
people on
Thank you
campus.
so much.
And this is in Maryland, right? So this is also
Yes,
in the
NIST.
East Coast.
It's pretty close to the NIH.
Yeah.
Thank you. Thank you so much,
So
fans.
a lot of people here are in the Northeast. It looks like that's awesome.
Yay.
Hopefully I'll see more of everybody here soon. I haven't gotten to connect with a lot of people in the Northeast yet, so it's good to meet you all.
Yeah, no, we're so glad you joined. This is awesome. But yeah, everybody give Carolina, sorry, I said Carolina before, Carolina, a round of applause. We really enjoyed your talk, and we will hit our last presenter for today, who's Lyndsay Young. So Lyndsay, go ahead and share your screen and show us what you've been up to and where you're wanting to go.
Okay, so hi, I'm Lyndsay. I'm from Lexington, Kentucky, so we're smack dab in the middle of the United States. And when I chose to go to college, I actually, as a little girl, I've always wanted to be a dolphin trainer. So obviously Kentucky is in the middle of the United States, so it's not really easy to like find an ocean here. So I decided to I headed to the coast. So I did my undergrad degree at Coastal Carolina University in South Carolina. So this is actually my building where I did research, and it was probably the best decision I ever made to go to the beach because I really realized my passion for living near the coast. So at Coastal, I acquired 2 degrees, one in biology and one in marine science. And this is my mentor over here at graduation. He handed me my degree on campus. And that was really cool to see like how I grew with the 2 degrees and changing my passions from marine science to research. So I actually joined his lab as a freshman at Coastal, and we were able to work with C. elegans to study neurodegeneration. So in my time there, I was able to publish 2 articles. I also mentored 2 other undergrads and presented my work at different meetings in different formats, including poster and oral presentations. And I won 2 awards, which was awesome because I actually don't enjoy presenting at all. So I'm really trying to work on this whole process. So by doing that research and learning how I wanted to really shape my life around being at the bench, I really started to pursue a lot of different activities. And I was actually awarded the Outstanding Biology Student of the Year when I graduated. So that was really cool to see that all of my hard work, because I played volleyball, I was a learning assistant, and I did research. So it was a really busy time as an undergrad. So being at Coastal, I then, I hadn't decided what I wanted to do with my life until I graduated, and it became like the fall of 2017. And I was like, oh crap, I have to figure out what I want to do. So I then started to look into programs. So I thought, I love research. I love doing everything about research, mentoring, not really presenting, but here we are, working at the bench, communicating with people. So I decided to pursue a PhD. And I actually came back home. So I applied to 5 different programs along the East Coast, kind of all over the place. And when I interviewed here at the University of Kentucky, I kind of fell in love with the person my whole interview process. So because I was here, I had like a unique experience where I interviewed on a Thursday, and it wasn't like a whole like PhD program interview. And my mentor currently actually interviewed me, and he challenged me in the interview. And I thought that would be a really good place to start because he challenged me from the very start. And I figured if I wanted to grow as a scientist, he would be the person to be my mentor. So here at UK, this is my building. I'm actually sitting at this intersection right here. It's a beautiful building. We have a great research facility here. I'm working towards a degree in molecular and cellular biochemistry. I have published 17 articles so far with 7 in review. I have a patent for treating cancer with glycogen accumulations, and I've actually assisted in several different manuscript reviews, which for people that haven't participated in those, it's working with my mentor, as you see here on the left, and reviewing papers that he's asked to review for journals. And I want to be a PI. So I think he has given me every opportunity to really learn the whole process of being a PI. So really those manuscript reviews and seeing how stories come together has really helped shape how I pursue my PhD. I've mentored 4 other graduate students, 5 undergrads and 1 high schooler. And again, as I don't like presenting, but I like to challenge myself, I presented at 13 different locations, including poster and oral formats. I was awarded a fellowship my 2nd year here, which was really cool for how my research has progressed. I was then awarded a Rising Star Award, which is also really exciting, and then a mentoring award. And now I'm a NCI F99K00 fellow because my project is actually in cancer. So a little bit about my project. We study this carbohydrate called glycogen, and it's a molecule that's important for regulating osmolarity and energy in a cell. And we study a variety of different proteins that are involved in glycogen synthesis and degradation. So glycogen is a carbohydrate, which most people don't use mass specs to study. So we developed several different techniques by mass specs to study this carbohydrate. The first was published in Carbohydrate Polymers, which I'll just go into a little bit. So typically glycogen is studied by doing an enzymatic assay where you collect the glycogen out of a system. It could be a tissue, it could be a cell. You then purify it and then break it down by enzymes and measure by a fluorescent plate reader. But we decided to utilize this same process and actually shoot some glycogen through a mass spec, which we first tried to do as a whole glycogen, which did not go well for that mass spec. So when we decided to start to interrogate glycogen itself, we utilized a process called acid hydrolysis, where we break the glycogen down into glucose units. And glucose is something that we can measure on our GCMS system. So we employed this to measure glycogen in a variety of different models. And we get a nice sensitivity and diverse range. We can profile single cells all the way up to a liver tissue from a human. And we really get a nice read. So this was my first work in really employing mass spec to study a biological system. So next we published in Journal of Biological Chemistry, which is a really biochemistry heavy journal. And using that process of isolating glycogen from tissue, we decided that we want more out of our sample. So we developed a metabolomics workflow with isolating all the polar metabolites, the glycogen, and the protein from your sample, and analyzing all of it on a mass spec. So we really get a 3-in-1 approach from a sample and really get the maximum amount of information from our samples. And importantly, we analyze our insoluble fraction, which has our glycogen in our protein. And really by doing this process, we're not performing a BCA assay where we just do total protein quant, but we can actually quantify individual amino acids in these proteins and really sum them up to allow for really improved rigor and reproducibility. So it's a nice whole application of this learning from how mass spec actually worked and applying it to get even more information out of our systems. And then finally, most recently, we're working in imaging mass spectrometry. So this is the meeting I just went to. I actually presented at that meeting. And we have applied this imaging workflow, which is typically using PNGase-F to profile N-glycans, which is a cool carbohydrate. But since we love glycogen, the other carbohydrate in the cell, we decided to utilize the enzyme isoamylase. And isoamylase actually cleaves glycogen at 1,6 branch points, which let us quantify chain lengths of glycogen by our Waters MALDI. So we really get a profile. We can do purified glycogen, we can do glycogen in a system, and we can do glycogen spatially in our models. And I apply this to, I apply all 3 of these techniques to a cancer called Ewing sarcoma. So Ewing sarcoma is the second most common pediatric bone cancer in children and adults, and it has a peak incidence of 15 years old. And when kids are actually diagnosed with Ewing sarcoma, it's typically mistaken for bone growth because, at 15, you're growing like a weed. So you never know what's going on in your body at that point. And when these kids actually do go to the clinic and get diagnosed, 1 in 4 of them have metastasis already. So it's a really aggressive growing bone cancer. And if those kids that do have metastasis of their cancer in the first 2 years of their life or of the diagnosis, they only have a 10% survival rate. So the current workflow for treating Ewing sarcoma is just chemotherapies. But most of my PhD is focused on characterizing glycogen in Ewing sarcoma, and then using that to really develop preclinical models and utilize drugs to target glycogen, thus sensitizing the cancer to chemotherapies. So just a little example of our MALDI IMS work, we were able to acquire several different Ewing sarcoma tissue samples. So over here on the left, we see an H&E image. The tumor is in the purple, and then we have the nice stroma and adipose tissue. And with all of our models of using mass spec to really profile glycogen, we were able to show that glycogen is specific to the tumor. And I have a different models for interrogating this glycogen, and we've really gotten some promising results in characterizing targeting glycogen is important for Ewing sarcoma treatment. So my next steps, I've done a lot during my PhD. I absolutely love everything I do about it. My lab is up here on the left where we have a sponsored project with St. Baldrick's. Here's me presenting last week, some friends. Here's a poster session, me with my nude mice that I work with, and a bunch of my undergrads down here. And I really want to just continue all of this work, specifically with mass specs. I freaking love mass specs and I love science. So I just want to continue all of this, and I want to be a PI. So my next steps really are focusing on the East Coast. So I want to do a postdoc at some institution somewhere along the East Coast, kind of in the Maryland area, because actually my boyfriend and our dog live in Baltimore. So I want to focus around that area. I would like to not do long distance for another 5 years. It was a little hard, but it actually helped my PhD progression. So yeah, that's my story. Just want to thank my massive lab for all of the support. And here's my Twitter handle if you want to follow me on Twitter, kind of active. And then there's my email if anyone has any questions.
I think Nathan would be a great match at Baltimore.
I was gonna say, I mean, I'm in Baltimore too, by the way, so I'll send you my email address.
Okay.
Yeah,
I love your dog.
That was awesome, Lyndsay.
Thanks.
Have you considered Philadelphia?
I have considered Philadelphia. I know some of your work. So
Well, I know your cell metabolism paper with the nuclear glycogen. So I saw your name on here. That's why I popped on, because I wanted to say hi, and so that was really cool. I also know your work, Nathan. The one pot acetylome and succinolone paper.
Oh,
so
yeah.
it's cool to see you on here too.
Yeah.
That's awesome.
Yeah, good to see you too. So you're about only 2 hours away from Baltimore, right? So pretty close by.
Yes. Yeah.
Or even 1 hour by train, so not too bad.
Have you been to the Baltimore Aquarium? I guess is a good question. Maybe get a side gig continuing your dolphin.
Oh yeah. Yeah. That's like plan F. If like everything in my entire life doesn't go as I really wanted to, plan F is just to be a dolphin trainer. I got the degree, so I could just always pivot back. So
yeah. It would be kind of funny to see how many people on here wanted to do something with marine biology, because I definitely did as a kid. Like I wanted to go play with dolphins.
Yeah. I think in the chat, Allison, who works at HTX with the HTX company, she said she wanted to be a dolphin trainer, and so did Ling. So I think there's quite a few of us that wanted to.
That's awesome. Any other questions for Lyndsay?
Oh, I have a question. So thank you so much for presentation. Great work. So you mentioned, so there's a lot of glycogen in the tumor. So how would you target that? Like, so it would be like a target delivery, or like, I don't know what's the plan to I guess, how do you say that? Break down that glycogen?
So we have multiple different inhibitors towards those enzymes that either make glycogen or degrade it. And throughout not only my work in cancer, but I'm actually in a neurological lab. Like we study epilepsy here. I'm the only cancer project, so I'm really guiding that one through. But we utilize different techniques, including just small molecule inhibitors, enzyme replacement therapy, protein targeted therapy. So I'm really applying all of that in our model. But it's basically the goal is to treat the tumors for inhibiting glycogen synthesis, which makes the tumor kind of freak out. So they're like really finicky. And then when that chemotherapy comes in, it's a more efficient treatment. So I'm not saying that glycogen is important for the cancer, but the way that we're going to use our small molecule therapy is to in conjunction with the chemotherapy, so that improves outcome. So yeah, so it's all kinds of different stuff. I think we have 2 cell metabolism papers on inhibitors. We have one on inhibitors and one on an antibody enzyme fusion protein, which is cool. So I can send those to you if you want. It's a really cool therapy-based thing.
Very cool. Other questions? I want to, after you said that you didn't really like presenting, I think that's really common with scientists. We're all kind of introverts, and like getting out there is very, very tough. So I think it helped me a lot. My first presentation, I think, was a total wreck. My voice was really high. I could barely breathe, and I felt like I was squeaking through the whole thing. And then I had somebody who was really famous to me be like, "It's okay, I did the same thing." And I was like, "Oh, good." I thought my career was like washed. And so I think it's totally common, and that's just one of the kind of necessary evils in order to promote the science that you want to do. So I'm glad you're getting out there. I think anybody that is scared of it just needs to get out there. The more you do, the better you get at it.
Yep. Yeah, that's exactly why I present. I love sharing science, and I freaking love science. So the only way to keep science going is to present it. So I might as well challenge myself. I like to always strive to make myself better every single day. So like doing this today is way out of my comfort zone, but we're here. So and we did it. So we're good.
Yeah, you know, and everybody did awesome today. So three amazing transition talks. So
I think it's a good point, Erin, and just to double down on that presenting, even when you hear, you know, the Beyoncés and Justin Timberlakes of the world give interviews, still to this day, they will say every day when they get on stage to perform, they have that, you know, nervous, anxious feeling. So it doesn't go away. It's how you harvest it and channel it. And everybody has it. So I love that you made that comment, Erin, and humans are humans. And, you know, even Beyonce has that. So
yeah, no, I'm glad you brought that up, because yeah, I don't think I've ever given a talk where I haven't been nervous, even teaching. Like, even I come in and like you go to teach for an hour and it's like, I don't know this subject, like this part of this lesson very well. So that comes up and you're like, okay, we'll make it through it. But yeah, I don't think there's ever been a time I haven't been nervous to give a talk.
Yeah.
But yeah, awesome set of transition talks today. And make sure you guys connect in the chat. You can personal chat each other and get contact information or hit each other up on Twitter. But that's been one of the things we found with FeMS is sometimes people will be like, connect with me, and then they either forget the name or don't get the contact information, and then they miss that. So make sure you guys get connected while we're on here. We have 19 minutes left, so we'll do some networking, but we do have some announcements. And so I'll do mine really quick and then we'll see if anybody else has them. Next week, we're going to have a session on imposter syndrome for FeMS, and that's going to be the 22nd. And the talk is really, really good. I've heard the speaker talk before, and she talks about 4 different types of imposter syndrome and how to kind of overcome those different types of imposter syndrome. And so I really wanted to get her for you guys, and I was able to get her. It took me about 6 months to grab her. So please come if you have time, because it was a really, really powerful talk for me to go to when I heard it. And then Mobile Lion is going to be sponsoring our first FeMS in-person gathering at ASMS for anybody that didn't pop on early enough. So on Wednesday at ASMS, after the Females in Mass Spectrometry workshop, we're all going to head down to a really cool location. We're still getting that set. I haven't heard back from some of the managers, but I think I'm really close. But we're going to have just a great gathering and just get to meet each other in person and hang out. And there's not going to be anything very official other than just getting to see everybody in 3D instead of behind a screen. So just a lot of fun. So please, if you're at ASMS, please throw that on your schedule, and we'll throw more information in the email. I don't know how much we'll promote that on Twitter, just because we don't want everybody at ASMS to show up because the room space is smaller. So, but we'll definitely send out emails. So make sure if you're not on the FeMS email, sign up for the email list too.
I have a question about ASMS workshops. Are they going to be only in person?
So that's my understanding right now, because they told us that to have everything planned for in person for the Females in Mass Spec workshop on Wednesday.
Gotcha. Thanks.
But yeah, if I find out any different, I'll make sure I communicate that on Twitter too. But yeah,
so Erin, just to point out, I don't know if you saw what's in the chat about the session on the 22nd to record. I just didn't want you to miss that.
Yeah, no, thanks. Yeah, because sometimes I miss the chats, and so yeah. I'll make sure I get that recorded though, because yeah, Devin she's just an amazing speaker, and it's really, because I think we all probably suffer from some form of imposter syndrome, and it was really good to understand like tips she had to make yourself kind of help get over some of the humps that people can kind of get stuck in. So. But yeah, any other questions? Those are my only announcements. Does anybody have any other announcements?
No, I would just reiterate to what you said, Erin, is check the chat. You know, there are direct messages that aren't on the broader chat, but check your chat screen before logging off of the Zoom, because that's where a lot of the contact information is and you might miss it.
Yeah, so please do that. And so I'll keep that all up during our networking, but around 11:05ish, we'll be going offline. So make sure you get any information you have for contacts before, say, 11 o'clock. But now I'll do some breakout rooms. So if you guys have time, go ahead and stay on. If you're busy, we totally understand. And if you have to leave, but this is always kind of a fun time just to visit with other people. And I can totally leave you guys on. So stay in your breakout room as long as you want, because I have multiple computers. So I'll just leave this one running until I see everybody leaves. But thank you so much for joining, and a huge round of applause again for all of our transition talks. This is a really, really great session. So great way to start the new academic year for transition talks. But yeah, let me get the breakout rooms going. And if I see one gets a little funky from people having to log off, I'll move, you might see yourself move around. So here we go. You guys have a great time. I'll see you guys next Thursday. Bye, guys.
All right. Bye, Erin. Thank you.
Bye, everyone.
FeMS